In this video, we will be looking at question 1D of the tutorial and be exploring what will happen when we are faced with a system of linear equations which looks as follows. Now, if we look at this system of linear equations, what we find is that we have, in fact, three equations, but we have four unknowns, namely w, x, y, and z. Now, keying this into the GC and solving it using the method as illustrated in the previous video, what we find is that our GC would give us the following solution set, which looks a bit strange, and some of us might not know how to handle this. So now, I am going to explain how we are going to interpret this set of answers and translate it into a proper presentation for our work. Okay, looking at this set of solutions, what we find is that we know that x1 actually corresponds to w and x2 it corresponds to x. But what does this tell me? If I look at the first equation, I find that x1 is defined in terms of x2, which tells me that w is actually written in terms of x. Correspondingly, I find that my value of x is not fixed. X is equals to x. Isn't this true all the time? Yeah, so bearing this in mind, I know that x is equals to x, which is always true. So x can in fact be any value. Now looking at the last two equations, I know x3 corresponds to y, x4 corresponds to z. So to write down my solution, because I know that x can take on any value, I will let x be equal to s for all real numbers, which means that x can be any real number. Now, once I know that x can be any real number, then from the first line, which says that x1 equals to 1 plus x2, I know that w is equals to 1 plus s. Now, from the third and fourth lines, because y and z are always equal to 0, so then I have no other way to write it but y equals to 0, z equals to 0. How do I interpret this? This tells me that in fact this system of linear equations, it has an infinite number of solutions, because any value of s that I substitute in will give me a different point that satisfies this set of equations. For example, if I were to substitute in a certain value of s, such as s equals to 0, then I would find my x-coordinate will take on a value of 0, since I am told here that x equals to s. Correspondingly, my w-coordinate will take on a value of 1 plus 0, which will be 1. And this will give me the set of points 1, 0, 0, 0. So I know that 1, 0, 0, 0 must satisfy this set of linear equations. Moving on, I can also substitute in s equals to -1, and my similar calculations, because s equals to -1, x will be equals to -1. So my x-coordinate here is -1. Similarly, my w-coordinate will be 1 plus -1, which would be 0. So I know that the point 0, -1, 0, 0 must satisfy all three equations. Finally, let us look at one more example. If I were to substitute in s equals to 1.5, then once again, from this equation, I know that x is equals to 1.5, whereas w will be equals to 1 plus 1.5, which will give me a value of 2.5. Hence, I know that the point 2.5, 1.5, 0, 0 will satisfy all three equations. Looking across all these 3 points, what I notice is that the y and z coordinates must always take on a value of 0.